You a little bit about this lesser known language called Elixir. Why is it cool and why is it amazing? My name is Janis and I currently work at Printful. So if we want to talk about Elixir, first we need to speak about this guy because he's the one who started it all. So his name is Jose Valam and he's the creator of Elixir. He was a guy who was working on Ruby's core team, and about 8 years ago he was trying to solve some concurrency issues within Ruby itself. And well, he ended up creating a new language. So Elixir is a dynamic functional language designed for building scalable and fault-tolerant applications. And the interesting part is that it is built on top of Erlang, and it runs on Erlang's virtual machine called Beam. And so it compiles down to Erlang's bytecode, and you can run any Erlang code or any Erlang packages within Elixir with zero performance hit. And as I mentioned Erlang, we need to talk about Erlang itself as well. So Erlang is not widely known language as well, but it is a general purpose language that was designed by Ericsson in the 80s, and it was released in 1986, I think. And its primary goal was to handle systems for telecom switches. So it was a language that was designed for telecommunication needs. And if we think about switches themselves back then and still now, they are small devices that doesn't have a huge amount of computational power. And the thing is with them, they have large networks of these switches, huge clusters of these nodes. And so Erlang was designed to run code in parallel on all of these switches within the same network. So it's distributed by nature. And if we think about the evolution of CPUs today, CPUs don't get too much increase in cycle count lately, but what they get is increase in CPU cores, right? So we have multi-threaded devices like mobile phones and all of our computers. They don't have single core, they have multi cores now. And this is one of the reasons why Erlang is becoming more and more popular after 30 years, is because it can leverage this. It can send a message and it can run code on multiple threads, and it was designed for it. And another cool thing with Erlang is fault tolerance. Erlang's core principle is let it crash. If something goes wrong within a process, it just lets it crash and spawns a new process in place to do the work. And because of this, Erlang systems are known to be highly available. And by highly available, I mean there are systems that have up to 99.49% of uptime per year. That's like 30 seconds downtime a year. And that's pretty cool, I think. Another thing what Erlang has built in is hot swapping code, because if we imagine we have a phone conversation going on and the telecommunications company needs to put an update, well, what we will do, we will take the whole system down and push a new code. No, that's not the best way to do it. And because of this, Erlang is designed that it can have multiple processes running on an older version of the code, and some processes are turned to the new one. And who uses Erlang? Well, small companies like Amazon, Facebook, Ericsson, and WhatsApp, for example. A couple of years ago, WhatsApp rewrote its whole system on Erlang, and the story is that they went down from like 26 servers to handle a couple of connections to something like 2. But then let's return to Elixir. So Elixir is dynamic functional language that is designed for building scalable and fault-tolerant apps. Let's look at the first keyword here, which is scalability. Elixir code runs into lightweight processes we call threads. In lightweight threads that we call processes. And it looks something like the actor model. And what actor model is we have small processes that are isolated from the rest of the system, and they have their own internal mailbox. And these processes can send messages to another process and receive messages and exchange with these messages. But since they are isolated from the rest of the system, it is possible to have many of them. Like it's not uncommon to have hundreds of thousands of processes running concurrently on the same machine. And this isolation allows these processes to be individually garbage collected, and this reduces system-wide pauses, and the machine resources are used more efficiently. So Elixir is great for vertical scaling. And of course, since, as I already said, that the cool part is that these processes can run on different nodes or on different cores in different threads and still send messages and exchange with the messages. So we can have very good horizontal scaling as well. The other key thing here is the fault tolerance. So, as we all know, things in production sometime will break eventually. And how Elixir works around this issue is it has something that's called supervision 3. So we have supervisors that supervise processes. And if something goes wrong with the process, it just kills it and spawns a new process, returns it to known state that's guaranteed to work. And of course, supervisors can supervise other supervisors, and this creates this kind of tree where everything is supervised and known to work. The question is then, but why we need Elixir? Why can't we just work with Erlang, right? Well, one of the key things here is the Erlang syntax, and this is one of the reasons why it didn't have high adoption yet. As we all know, developer happiness is quite an important factor, and let's just say Erlang syntax is not the easiest to get used to, and it's just so strange, and it looks way differently than other languages that we are used to work with. And of course, it's not the only thing that Elixir changes. There are some other cool things that Elixir brings to the table. But basically, what Elixir is, it's a sugar layer on top of Erlang, where it adds a Ruby-like syntax, and it compiles down to Erlang's bytecode. So we can still use Erlang's VM and OTP. So let's check out a little bit about this Elixir. Of course, we have types, and Elixir is dynamically typed language. We have types like integers, floats, booleans, atoms. We have lists, of course, which are linked lists. We have tuples, which is something similar to list, but with a known count of the elements. And we have interesting types as well, like, for example, maps. Those are like objects in JavaScript, but then we have keyword lists, which is basically sugar layer on top of list that has tuples with two elements. It has an atom. First one needs always to be an atom, and the other one is a value. And then we have maps. We have structs. Structs are map just with defined structure. We have types like regular expressions, we have ranges or streams, we have process system types like process ID or ports, and we have functions. Of course, Elixir is functional language, so we have to talk about functions. And usually the functions are combined within a module. You don't have to have it, but it makes the code a little bit more tidy. And one module could have multiple functions. So you have parameters, and you have a value that's returned. Every time you have the last line in a function, that value will be returned. And when you execute a function, you can have parentheses, or you can just leave them out. Of course, we have anonymous functions, and that's about it about the functions. But let's dig into the pattern matching, because pattern matching is one of the nicest things, in my opinion, about functional programming, and Elixir, of course. The equal sign in Elixir is not an assignment. So equal sign is treated as the match operator. It will match what is on the right side to what is on the left side. In this case, it's a new variable, and we assigned it value of 1. So if we just type in 1, we will return the value 1. But if we want to match to something else, for example, we assigned 1 to x, and then we are trying to tell that 2 is x now, it will throw an error, because Elixir is immutable language, and Erlang is immutable as well. Well, Elixir is slightly different in the way that you can still reassign variables, but they will not, Elixir will not override the current existing value in the memory. It will create a new memory pointer. And we can have pattern matching within structures as well. Like, for example, if we have tuple, we can match some variable that's not assigned yet to a number, and it will assign this variable to this number. Or we can create new lists. Very often in Elixir, you see that function will return two-element tuple. The first element in this tuple usually will be a message like OK or error, and the other one will be the result itself. And this, it makes it really easy to use pattern matching within a function calls, like in the case statement. You get, if the result is OK, you do something, and if the result was something unexpected, like error, then you do something different. You can use pattern matching within function definitions themselves as well. For example, we have divide function that's defined here twice, and in the first time we define it that the second attribute will be 0, and the first one will be a number. And as we know, we can divide by 0, then we throw an error. And if it is OK, the value is as expected, not 0, then we can do the math. And you can even go a little step further. You can add something that's called guards to the functions, where you can specify what kind of type of each variable, of each attribute you expect. If you pass something else within that attribute, it will say that the function is not existing. And the pipe operator. Let's take an example. So we have three functions that we want to apply to a function, to a string. For example, we want to trim it, we want to strip it, and we want to turn it into uppercase. So normally we have two options. We can either cast each function in the next one, or we can assign a bunch of variables that pass the values within them. But this syntax, in my opinion, both of these ways are not the best. The better one is the pipe operator, in my opinion, where you have the pipe operator passes whatever on the left side to a function that's on the right side as the first argument. So in this case, we get an input, we pass it to the strip function as the first element, the return value of the strip function will be passed to the trim function as the first attribute, and to the to upper function. You can have these in multiple lines as well, and you can leave out the parentheses if you want. Of course, in 15 minutes, I can't tell much about a whole language, but there are some other cool things like testing. Elixir was designed with testing in mind, and this means that, for example, when you create a function, you write documentation within dog blocks for it, and then you can write the test right there in the dog blocks, so you know what's the input parameters are expected, you know what the return value is expected, you can have the test there as well. Mix is a build tool that handles testing, compiling, creating applications, managing dependencies and stuff like that. We have Hex, which is package manager like NPM for JavaScript, but for Erlang ecosystem. We have Erlang's Observer, which is a built-in application within Erlang, where you can visually see all of the processes, how they are spawning and how they are managed. And we have OTP, which stands for Open Telecom Protocol, but in truth, it has nothing to do with telecommunications anymore. It's just a collection of libraries that solve issues like state management, application discovery, failure detection, code hot swapping, and stuff like that. And we have Phoenix. Phoenix is a full-blown MVC framework, and it's just amazing to work with. It has stuff like sockets built in, and it's very, very fast. And quickly, I want to show how it looks. So right here, I have a local server running, and I have 3 endpoints. So as we can see, it's a simple endpoint that returns just a full bar key value pair. Wow, sorry. Yep. So yeah, we have a simple application where we have just a simple endpoint, and we have a key value pair returned. And on the other side, I have this Phoenix running as a local server, and we can see that it executes. And it executes very, very fast. The server time is normally under a millisecond for Elixir, so it's quite fast. Here I have a function that counts from 1 to 50, and every time it iterates, it sleeps for 20 milliseconds, like let's say there's some kind of query that needs to be run that's quite slow, so it iterates, and of course it takes a bit over a second because each iteration takes up to 20 milliseconds. And in this case, I do it the same thing, just parallelly. So I execute the code, the same code, but it spawns a process every time I want to do this, and each of those processes will sleep for 20 milliseconds. But since it's multi-threaded, it's parallel, as we can see, the order is quite random, and each process handles the connection differently. And since it's sleeping, other stuff can work on the same time. And from code, it doesn't look very differently, so we have the same thing. We have from 1 to 50 count, and we just loop through it. And in this case, we just call another function. We don't call enum map, we call parallel map, which is just the same enum map, but with task async and await within it. So it spawns processes, and this way it just works. So yeah, that's about it. And if you have any questions, you can ask them or grab me later if you want. Any questions?
Do you use it in production?
I have used it. We don't use it in Printful. So the question was, do we use it in production? I have used it in another company where we solved an issue. We had pretty bad PHP code, and we had to calculate results for surveys, and it was quite a complicated process where the calculation of results ran for about 5 minutes. Yes, 5 minutes. We rewrote the same endpoint in Elixir, and the result was in 200 milliseconds. So the performance gain, of course, the PHP code was quite bad there, but still, if we made it like it should be nice PHP, it wouldn't be 200 milliseconds for sure.
So are you trying to push it to other developers in Printful?
We don't have a good use case for it yet, because one of the things is it's a new language and not many people know it. I would love to write some Elixir there, but we'll get there, I hope so. Because the parallelism is quite amazing there. And the language is quite easy to work with as well. Yeah, another question?
What is the state of the ecosystem? Like, if you want to have a database like MySQL?
So what is the state of the ecosystem? Ecosystem is actually quite mature. Usually the Phoenix comes with when you install it, it has its own database wrapper called Ecto. It's something similar to ORM, but not really an ORM. It's a query builder. And it has drivers for MySQL, for PostgreSQL. By default, it installs with PostgreSQL drivers, but you can use MySQL as well. I'm not sure about other databases though. But Erlang has its own database built in. Basically, it has like NoSQL database called Nisha, and it has its own type of Redis as well, like in-memory storage as well. It's called ETS, Erlang Term Storage. Erlang itself is quite old language, and it has a large amount of packages as well. So the state is quite good,